I'm gonna start with this guy we tried to make yesterday. I actually made a mistake. I checked my tutorial from last year. Apparently the array, you don't do it in the curtain wall panel, you do it in the line-based family and then import the array. And that was kind of the mistake which wasn't making it work. So I'm going to fix that and show you how to use it with the same structure. So open up the line-based family you created yesterday. Let's quickly fix that file and then we'll move on to other examples. So this was the generic model we imported using a profile, right? And what you have to do is go to an elevation view. So that's my profile. I guess I updated it. And I'm going to move this guy. Let's see. Oh, this is a sweep. So let's bring in the component again. So I'm going to create the component. Open up the desktop. And I want to bring in the sweep. Right? So the profile was used to create a sweep. The sweep we're going to use to create a line-based family. And in the line-based family we're going to make an array. And then we're going to import the array into curtain wall panel. So I'm going to open that up and go to create component and place it somewhere there. Now we'll be able to flip the direction of this, so it doesn't really matter. You can just place it somewhere here and then use the align tool to lock it on the left side and lock it to the reference line. And then what you have to do is go to the component's parameters. So this is the component's type parameter, the width, and we want to associate that to the length of the line-based family. Hit apply and hit OK and make sure that this is stretching. Right, that's basically what we did yesterday. Now the part that we didn't do is to align this at the bottom of a reference plane and then create a secondary reference plane on top and then create a vertical array. So let's do that. So I'm going to create a new reference plane here and do the array in the line-based family. So select the component, do a vertical array, I'm going to do a line. I want to align it here. Let me see if we have to change the number. Yeah. We have to do this guy as when you do the array, choose this one, choose the last, move to last. I'm going to move this guy here and enter a number, let's say 5. I'm going to do a line, lock this value and make sure that the left side is aligned as well, so that the line-based family is stretching or behaving the way you want it to behave. So this is kind of working. And I'm going to create the louver parameter here. So choose this number, define number of louvers here, define it as an instance parameter, hit OK. So now this is flexing. So I'm redoing the exercise from yesterday. I am using the line-based family and creating a vertical array in the line-based family. That was the mistake. We are not doing the array in curtain wall family. We are just going to import this as a system into the curtain wall panel and lock it to the dimensions of the curtain wall panel and use it as this. So that's kind of how this works. So if you line up, when you create the array, this last item, line up a horizontal and a vertical side of it. Did you do that? Okay, let me see. I'm going to save this guy and open up the louver system. I think this was the curtain wall panel family I had. Yeah. and I'm going to delete the array here, and I'm going to basically import this line base family there. So I'm going to do load into project, go to reference level, create component. I'm going to choose place on work plane. So this option, the plane, is basically you're defining the kind of a reference to use when you're placing objects. We'll be looking at this more in detail in massing. So I'm going to do place on work plane and then draw a line. Right? When I draw the line, it's going to place the component, but now my component is actually a vertical array. I'm supposed to get a vertical handle here. Let me see if I have to create a parameter for it. So let's go here. This is locked, but I probably need to create a height parameter. So I'm going to create a height parameter inside the vertical louver family, the array. So create a vertical annotation. Choose this guy. And then add as a parameter, let's call it height. I'm not sure if it was type or instance, but let's keep it as instance for now. So I'm going to hit OK. So it's just a parameter we are creating. And then save it. Load it again. Now, when I choose my louver array in the generic family, I will have a handle here. This handle is pretty important. If you can't see it, that means you need to create a vertical annotation inside the array, because this allows you to snap or reconfigure the height parameter for that array. So I'm going to move it here and lock it. So now what I have to do, let's move it here. Let me see if we have, let's do an align, lock it there. This side is locked. So it's basically flexing pretty well, right? So the top and the bottom, everything is locked. You actually don't need this parameter anymore, the width parameter. This is kind of in a generic curtain wall panel family. So this would work. It's already locked, because we don't know what the dimensions are going to be for the panel, the width, the height. The only difference I did from yesterday is the line-based family. That's where you have to create the array. So you bring in one component, we did with the sweep, and then create a vertical array for it. And then for the vertical array, you need to create a top panel, plane, and then use that to create a height annotation. And then this height annotation, when you import it in a curtain wall panel, the last family we are creating, it gives you a handle to snap it. So it's kind of a flexible element. So that's what I did here. And you don't need any annotations here, because the division could be anyway, right? We may want it to be not informed by the division. Bless you. Now let's create a new project file. And I'm going to bring this louver system into that. So let's look at what we can do with it. So go to wall, curtain wall, draw a line. Let's do some divisions. Then I'm going to choose the whole system, go to edit type. On the curtain panel, I'm going to choose the louver system. And it's working with the constraints, right? And if I go in 3D, let's see if we can customize the number of louvers as well. So this parameter is coming in from the panel family that we had. So if I go to edit family, that's this parameter that is not associated anymore, so we can delete this. We basically don't use it. And let me see. So this guy has number of louvers here. So maybe we could use that. So let me load it back into the project. Say what? So if you're not seeing the handle, that's because you didn't create a height parameter in the line base family. You need to create a line, like a height. You did? You did? This is an instance parameter in mind. The height is an instance parameter. Did you set it up as an instance parameter? The line base family. The height parameter is an instance parameter. This guy. And this is fully locked to this, so it flexes. And then you load it into the lower system. And then you should see this handle when you select it. If you don't see it, it's fine. Sometimes, like, you have to redo it. I had these issues many times. Sometimes, like, it doesn't work. Sometimes it works. In the first one, like, if you're missing a little step, it may be creating a little glitch. But I don't want to waste too much time on this because I'm going to upload the tutorial of this specific exercise, so you can review it and redo it yourself as well. What I want to do is, let's go back here. I want to see if we could bring in the number of louver parameter that we had. So if I go to edit family, this is the curtain wall panel family, and the number of louvers is associated here, right, within the component. So if I override it here, it changes the component's parameter, but we don't see it as a type parameter for the curtain wall panel. So what you have to do is create a parameter under the family type. So you can just like create add parameter and call it number of louvers again. Make it an instance parameter. And the type of parameter is going to be an integer. Right? You can specify the value here, hit OK. And then you want this parameter, let's say we give it a number. Say we make it 5. Hit apply, OK. Now when I choose this guy, I want to link its internal number of louvers to that parameter, so that I'll be able to control that parameter in the curtain wall panel family. Right? This is similar to what we did yesterday. So that if I want to use this parameter, like I want it to be accessible to me, so I need to use it in the final family that I'm creating. I need to create a parameter for it, and then link it to the parameter I want to control in the subcomponents.
So, in mind, in the curtain wall panel, when I go to family type, I still have the number of louvers parameter that I set up.
That was the old one. So yesterday we created the array inside the curtain wall family, and today what I did was instead we did it in the line-based family. So when you bring it, that parameter is located here. So you need to create something else here to link it back to that. Right?
Okay.
Do you guys want me to?
Well,
So that's what I did basically. Now I could do the same thing. I could select these and give them custom values because I have a parameter for them. Okay. So let's see. I want to do another quick example to show you rotation. Yeah. How do I make the divisions? It's a curtain wall. So choose the curtain wall. go to curtain grid, you can make vertical or horizontal divisions, right? And then I basically applied the same thing. I chose the curtain wall, and for the panel, I chose the louver system that we created, and then you can choose in individual panels. So this is actually a panel, right? When you create a curtain grid, you're defining or dividing it as a panel. And now that's the boundary for the curtain wall family that we just created, so you can use it here. I'm going to do another exercise. I think it will like double stitch things, so I think it will make more sense. So let's look up rotation in families, how to approach rotation. And I want to show you can also do formulas and like statements or like other types of complex parameters. Let's create a new family. And this time, we're not going to do another nested example. It's going to be really straightforward. So I want all of you to follow this actually. Let's create another curtain wall panel family. Okay, just open one. So now we have something like this. Now I'm going to go to an elevation view, and I'm going to create a panel that can fold or extrude. So it's going to basically have a profile. This is an example I did last. Let's do the vertical one. If we have time, I'll do a horizontal version. So for this exercise, we're going to start with the reference lines. So far we have been working with reference planes. Now we're going to look at what reference lines do. When you want to have rotation inside a family, you need to use the reference line, because planes cannot rotate. Planes are perpendicular. So I'm going to choose a reference line, and I'm going to come in here and draw an abstract line like that. And the other one I'm going to draw here. Now what you want to do is lock this point to the intersection of these two planes, so that when you move, it kind of moves along with them. To make sure that you have locked it, choose the line, click on this point, and lock this relationship. Click on it again, and lock this relationship. Okay? So that when you move horizontally or vertically, this reference line is, this point is locked in that place. I'm going to do the same thing to the guy at the bottom. So I'm going to click here. They are overlapping here, lock this constraint, and then click here, lock this constraint, so that it can rotate freely in this direction. Okay? And then try flexing it to see that it's locked. Then I'm going to go to annotate, angular annotation. I want to annotate this reference line to this plane, put a degree value there, and do the same thing here. Now what you want to do is choose this value, go to the label, add parameter, and type in angle. This is going to be the angle of rotation, and the type of parameter is an angle, right? And I'm going to make it an instance parameter. And hit OK. And apply the same parameter to the other angle as well, so both of them use the same. Now, we could separate or differentiate these two, which will generate more interesting forms. But first, I'm going to keep them the same to show you how you can do this. Now, technically, I can offset this reference plane, create a length parameter there, give the panel some overall thickness. But for the sake of simplicity, I'm just going to make it into a triangle, okay? And just a triangle extrusion and work with that. So go to create. I'm going to do an extrusion. Now what you want to do is create a line here, create a line here on this line, and create a line here. And you want to move them and lock them to the lines they are placed on. right? So when you see this locked relationship, you want to lock them. So you want to move it away and move it back onto the line and lock it. Or you can just simply lock it when you're drawing it as well. So I'm going to do the same here. Lock that relationship. And then you have to connect these lines to generate the profile. Choose the reference line and click on the point, the end point. Once you click on the point, you will see the lock signs. And you have to do it twice for both vertical and horizontal. Then I'm going to go to Modify, Trim Extend to Corner. I'm going to join these corners. Hit check. Now I have a simple extrusion here. Now let's see if the profile is working. So I'm going to go back to my type property. Under angle, I'm going to enter a different angle value. Let's say 15 degrees. Hit apply, and this will change. Just click on the point, the end point. I mean, if you want to get rid of it, just select it. Hide it. Just work here, you know. So after you do this, you have to go to the other view, to the exterior view. Now what I'm going to do is stretch this to this side and lock it, and then stretch it to this side and lock it. So now the plane extrusion flexes horizontally, and it flexes vertically as well, maintaining the angle constraint we set for it, right? So make sure that this is working. Yeah. And I'm going to save this as precast, and then load it back into the project. Now I'm going to create another curtain wall panel. Let's say this guy is here. Let's go to new curtain wall. And curtain wall panel system is going to be precast this time. Let's make a new one. Go to curtain wall, edit type, duplicate this, curtain wall 2, hit OK. So make a copy of the curtain wall instance, and then for the panel system choose precast. Mine is actually not there, so let me bring it again. Say what? Oh, it's just a generic project file, and I'm bringing this into that to use it. So I will create curtain wall 1, duplicate curtain wall 2, and this guy is going to have precast for his curtain wall panel, and I'm going to draw it here. And now if I go to 3D, this has only one division, so it just gets one panel, right? Now I'm going to subdivide this into segments. So let's go to the elevation, choose this guy, and I'm going to do curtain grid and make tons of divisions. Let's make I'm doing all vertical, so that's like we can see what's going to happen when I create a formula. But basically I created segments, and this is the panel. You have a question? Say what? Size. What I want to do is somehow automate the panel extrusion or the angle of rotation in relationship to the area of the panel, so that we could say if the panel area is too large, fold it like less maybe, and then if it's like small, maybe we fold it more, so we can control or link the angle of rotation to the size of the panel. And to do that, I'm going to go to back to the family, and I need to create some parameters here to link the angle of rotation and use formulas. So what I have to do is go to annotate, use the align dimension, specify a dimension for the width of the panel, and then specify a dimension for the height. And these guys are actually not going to be parameters we are going to override under the family type. They're going to be reporting parameters so that they will be extracted from whatever panel we are using them on. Okay? So I'm going to set this to be a height parameter. And the trick is to define this as an instance parameter and a reporting parameter. So if you remember what reporting parameters do, they extract a value from a geometric condition. So when I create a new curtain wall system, if I have custom divisions, the height of the division, the height of the panel that happens in the division, it will be used here as a height parameter inside the family. Right? So when I click reporting parameter, hit OK. If you go to type properties, that will be grayed out. That means it's a value that's going to be extracted from the project. Yeah. Yeah, you cannot change it because it's a generic value that you just want to extract. And the same thing I'm going to do for the width. So I'm going to create another label and label it as width and make it an instance and reporting parameter again. Hit OK. Now I have two reporting parameters under the family type parameters. Right? And what I want to do is use these two to calculate an area value. Right? How do I do that? I can create a new parameter here. So it's not a dimension parameter, it's going to be an area parameter. And it's not something that we can annotate in the project. So I'm going to create a parameter here manually. And I'm going to type in area. Now the type of parameter is going to be area. So you choose area here. And then it's going to be an instance parameter as well. But it's not a reporting parameter. Right? Because it's just a value that's going to be calculated using reporting parameters. Then I will choose OK. Now, here we have a formula section under the family types window. And under the formula, you can use other parameters that are used here as well. So for instance, if I type in height times width, hit apply, it will use this as a formula to derive the area value automatically, right? So whatever these height and width parameters are in the project, it will give me an area value, or it will store an area value inside the family that I can use. I could also say what? Yes, I want to extract the area of the panel as well, right? But this is also grayed out because now it's driven by a formula, and the formula is driven by reporting parameters that we're going to extract in the project. So whatever those custom divisions are, each of those panels are going to have a custom area. And you can even add parentheses here and further customize it, right? I can divide it by a number, multiply it by a number. I can normalize it if I wanted to. Let's keep it at as the way it is now, like height times width. Now the other thing I want to do is maybe use this area value to control the angle, right? And to do that, we can also create conditionals, like if statements. We can say if area is greater than this value, this threshold, use this angle, else use use this angle. Absolutely. And there's a quick lookup for that. So if you type in Revit formulas, the first link that comes out in this forum, this is a pretty good resource. You can look up basic formulas here on how to set them up as well. So there are conditional statements you can write there, greater than, smaller than, equals, some trigonometric functions you could use for rotations. But what I'm going to cover is this guy. It's like a simple if statement. So we could write if a conditional, do this. If it's not met, do that, right? So if length is less than 900, do this. If not, do that. And the nice thing about these if statements is they can also be nested. So you could write in a nested if statement too. So you can override or further customize the false conditional or the true conditional. So I'll do a quick example for this to show you how you can approach it. Did you do this as an instance parameter? Is this an instance parameter? Is this an area? Alright, make sure that you dimension the planes for the parameters. And for practical reasons, you could also make your parameters into single letters, so they are easier to formulate and use. Yeah. The hide them for. But I mean, they will be grayed out anyway. I guess it needs to show you the. Okay. I guess it needs to be stored somehow, like the value, so that these formulas do work. So I'm going to give single letters to the formulas I'm using. So now we have an area value, which is in square feet. And what I want to do is write a formula to use it. So I'm going to come in here. Let's look up the formula. We're going to type in if, open parentheses, some condition, comma, a true statement, comma, a false statement, and close parentheses. So the structure is basically if A is smaller than 30, comma, I want the angle to be, let's say, 45, else I want it to be 35, close parentheses. And when I execute that, it checks the area value within this conditional and then gives me the angle that satisfies it, right? So right now it's going to be 45. Now I could keep customizing this. I could basically come in here and replace the 35 degrees as, so when A is not smaller than 30, so that means A is going to be greater than 30. A is going to be, the area, the panel is going to be really big. Maybe we want to use smaller angles, right? So I could do if A is greater than 50, use 10, else use 25, and close it. So that's a nested if statement I placed there. I could do one for here as well. Huh? Do you want me to go over how I did it? So the structure is here, if you're asking. So I'm writing if area is smaller or greater than some value, use this angle, else use another angle, and then I can use another if statement here. Was that your question? Oh, what did I type in? I can redo it again. So if, open parentheses, A is my area, is smaller than 30. If area is smaller than 30, that means it's a small panel, right? If it's a small panel, I may want to use a larger angle so that it extrudes even more. But if it's a big panel, I don't want it to extrude a lot, so I want the angle to be smaller. So that's kind of the constraints I have. Yeah, I mean, it's kind of back and forth. I'm going to set up the parameters and the formulas, import it into the project and see how it behaves, and I can come back into the family and override or change them anyway. So if area is less than 30, let's say I want the angle to be, I can even use the area actually, right, or the width or height as a constraint as well. I can say use area as height divided by 10 feet, right, or width divided by 5 feet. Let's do that actually. Let's make it more complex. So if area is less than 30, let's do width divided by 5 feet, comma, else do height divided by 5 feet. Let's see. Well, we need to be able to convert into degrees. It's not gonna work that way. I may have to do arc cosine. Let's just enter the angles. Let's do 35 and 25. Right, so within this statement, it gives me 35 degrees as an angle. So I'm going to hit apply, hit OK. And let's load it into the project and see what it does. Override. Now, most of them have the same parameter. So let's see what's going on. So this guy has an area of 66 square feet. This guy has an area of 210 square feet, right? So those are the thresholds right now that I have in the panel. So I need to basically increase this area threshold. So if my area is less than, let's say, 100, I want to use 35, else I want to use 25. I'm going to hit apply, hit OK, load into the project. Now these guys are using a different angle, right? Because their area is less than 100. So their angle gets set to 35, and this guy gets set to 25. Right? So these are different too. So I can keep customizing this. Let's say we want to go to an elevation. Let's add more divisions. So I'm going to add some more divisions here and here. And then these guys, I'm going to do add remove segments. So I'm customizing basically the panels. This should be good. Okay? So now I have something like that. Okay? And let's check some of the panel sizes. So this guy is 22 square feet. This big guy is 150. This guy is 140. So I can technically make my if statement more complex for smaller and larger panels. Yeah. Do it. Oh, it does it automatically. Just type in the number. No, it gave me an error when I tried to use like a numeric value, like I want to use feet. But actually, let me see. What if I do W divided by 5? Would that work? And height divided by 5. No, it gives me an issue. There's probably a way to convert this into degrees. Yeah. You can use cosine. I have to look it up. There's probably a way to convert these into, like, use length values and use them into degrees. Say what? Huh? Make them an angular parameter? No, but can you use like height divided by 10? Oh, that's how it works? It should directly work if you type in height divided by 10. But the issue is converting the units. So because I'm using feet. Oh, it's that. Alright, let's try that. Let's try setting up a new parameter. Let's say angle 1. And this one is going to be instance parameter and integer, right? So this guy is going to be w divided by 5. And it gives me 1. Or let's do w divided by 2. Well, it's going to be 2 degrees. I could do inches, yeah. W divided by 2 inches. And let's try using angle 1 here and see if it works. The following is not a valid parameter. Angle 1. Let's try it again. Modify. Let's do this A1. A1. It says inconsistent unit still. Revit is not logical most of the time. 90% of the time doesn't work all the time. So that's from Ron Burgundy. Just set this as like fixed angle values, and my advice would be go back to the facade you want to create, look at kind of the average panel values, and think of like what the angle you want to set for those, right? So for the small area values, like the stuff that I had less than 20 square feet, they could extrude even more. But the large panels, you don't want to be gigantic, so you want the angles for them to be smaller. So technically what I want to set is, if area is less than 100, that means it's a smaller panel, so my angles could be larger. So under the true statement here, I could write another nested if statement and say if area is greater than 50, use let's say 45. No, let's say 35. Else use 45. And for the false part, which is a large panel, I want to use smaller values. So if area is greater than 150, I want to use 10 degrees. Else I want to use 15 degrees. Right, so now I have basically 1, 2, 3, 4 angle values that are fixed within certain intervals. And if I apply to that and hit OK, load it back into my project, now these will even change more, right? So some of them extrude more, some of them extrude less. No, this is pretty deterministic actually. That's not random. Like this is, I have divisions, and each division has an area value, and that area value helps me construct or define the angle of rotation per panel. No, it's just a triangular extrusion. It's really simple. Okay? Alright, I want to do a little bit of massing today, and because I'm running out of time. So let's look up some of the massing tools in Revit. I'm going to, let's see. Let's look up what the massing does when we use it directly inside the project. So go to the Massing and Site tab. And I want to create an Inplace Mass. Here. And give it a name. Let's call it Mass 1 is fine. Hit OK. Now, when you're in the massing tool, this basically enables you to play with volumes and model kind of a form and extract the surfaces of it to be used for the project. So I will just start with something simple. So let's create an extrusion. So I'm going to create a rectangle. Now if you want to turn it into a three-dimensional form, choose the profile and then go to create form. And what create form does is basically it looks at the profile and turns it into a three-dimensional or two-dimensional form. So in this case it can extrude the rectangle. And this is a dynamic modeling environment. So each time you see a handle, that means that object is stretchable. So I could stretch planes. So I could use a tab key to iterate between surfaces and elements of this massing and stretch it. I could also move points. So what's going to happen when I move this point? I'm going to get two ruled surfaces, right? It's going to distort these two surfaces. But basically I am playing around with the massing tool. Right? This is a three-dimensional object I'm creating. So let's say I'm testing kind of ideas for my building massing, right? The other option we have, or like you could also do void forms. I could create another form here, and this guy I want it to be, let's say, void form, and the void form extrusion. I didn't even place it in the right place. Let's do it again. Let's do set plane. Void form. It's actually looking for a placement. So to place this on the construction plane, I go to the rectangle, and you can draw on each of these highlighted surfaces, but I want to draw it on the ground plane. So I try to find the ground plane and then draw a rectangle there and make sure that's where I want it to be, and then you can choose the profile again, create void form, and that will be subtracted from the solid form, right? So it's similar to how we worked in the families, so solid to void form relationships. And then if you want to edit it, you can use the tab key to iterate through the elements you created. And then I can choose its vertices as well. I can move the void form extrusion and start customizing the shape of it. Here, for instance, I can move it here too. So it's basically a dynamic modeling environment. Now, one of the simplest ways you can approach using the massing tool is to, let's say, create an undulating surface like the precedents I've been showing you. Let me show you how you can do something like that. So I'm going to go to Massing Insight again and make another Inplace Mass. And this time, let's say we want to define a block that is the dimension of our massing. And then I'm going to do create form. And let's say the height is going to be 70 feet. Well, this is a big block, right? I'm going to do finish mass for now. Now the next thing I want to do is maybe undulate some of these surfaces. So maybe I want to articulate this facade here. So I want to use the tab key and choose that surface. Actually, I need to edit. I need to choose the massing, go to edit in place, then choose the surface I want to edit. And then if you come in here under form elements, we could add an edge or we could add a profile. And what I want to do is add a profile to the surface so that I can start moving it or playing around with it. So I'm going to do add a profile. And if you click any of these heights, you can add a profile to the massing. So let's say I want to add one here. Let's add another one here. And I want to add another one here. Now, if I come back and choose one of those lines and do edit profile, I'll be able to change the contour of massing at that level. So I can delete this line, come in with the spline, and give it any form I want. Right? So let's say something like this at that height. I'm going to hit check. Choose this guy, edit profile. Maybe this guy comes out a bit. And these are spline tools, so I could basically add control points or remove control points. So I can add more control points here if I want to have more control. And I can move them out. Yeah.
Does it show how far you're moving things in terms of
Displacement? Well, in its own term, sure. It's if I do this in the plan view, it will be easier. Well, now it's giving me an angle. But what you could do is, if you want to snap those points to specific lines, you can create model lines and snap to them. Yeah. Sure. So select the massing. Choose the massing. Once you're inside the massing, go to form element and do add profile. And when you choose like a level, it adds. Oh, so then basically choose one of the profiles you want to edit, like this guy, and then it shows you under context ribbon edit profile option. And when I do the edit profile, it highlights the profile, and I can just delete and override the element, right? So I can make this go this way, and maybe for the last one, say it again. That's a good one. No, it highlights both of them. I don't think so. Yeah, I didn't notice that actually. No, it shouldn't be a problem. But basically I'm creating a facade, right? So I'm creating some undulation. And that's what I got.
do you think we should come up with a scheme like this for the massing before we
You can keep it subtle. Keep it subtle. Make like you can do balconies like this. And the advantage of approaching it through massing is because the massing allows you to extract floor plates using the geometry of the massing. So I'll show you how to do that. So if this massing is right here, so let's say I want to get the contour at the level, like specific levels, like floor levels. I'm going to create an array of floors. So I choose level 2, go to array. I'm going to copy it, and let's say we want to have 7. Let's say array again. Yeah, second. So I created more levels. Now if I want to get the projection or the intersection of the level with the massing so that I can extract the floor plate, I simply go to the massing, choose the massing, and do mass floors. And here I could choose all the floors I want. Hit OK. It will calculate all the intersection, and it will give me a plate. And if I want to extract or define them as floor plates, I could go to Architecture, Floor, and hit the drop down. You can choose floor by face. And if I choose all of these, create floor, I'll get them as floor plates now. So I can use them. So I can basically create a twisting form, any type of custom form, and I can then divide it at each floor level to extract its floor plate. And then I can use them to draft or see what the outline of the shape is for that floor, and then customize the outline of my units to accommodate that, right? So basically, like those floor plans are not generated, but I could go to View, and Plan Views, Floor Plan, and I want to create one for each of these new levels I created. And for each of them, I will be able to see the floor plate, right? Right, so I'm going to hide my, let's hide the massing. That's my floor plate at that level. So I'll be able to use it to customize the outline of the units. Now this doesn't have to be curvilinear. I just made a curvilinear example. It could be polygonal as well. Right? You can make it any way you want. Let's make another one. Let's make another in-place mass. And this time, let's see. Let's see, I'll do, shall I do, let's do an ellipsoid. So you could also do lofted forms using the massing. So I'm going to come in to level 1. I'm going to draw an ellipsoid. Let's say something that is 50 this way and 32 this way. That's the shape I'm drawing. Now that guy is over there. Now you can actually set up work planes where you want to draw these profiles, and you can use them to input the profiles as well. So if you look up here, the massing tools is kind of a hybrid, right? It partially shows you the project and partially enables you to create family-based construction objects. So like we could set up reference planes, for instance. So I could set up, let's say I'm going to set up one reference plane here, another one at 164 feet, another one here. So it's like a really tall tower. I can also customize these intervals. So let's say this is 100 feet, and this guy I want it to be 100 feet as well. So I can draw 3 profiles and then use those planes to define the massing. So I'm going to go in 3D. I'm going to delete this shape, and if you want to draw on specific work planes, you could do set work plane, set work plane, and then you could do pick a plane. And let's say I want to draw on the ground plane. I'm going to hit OK. I want to choose this plane, and it's going to ask you like a drawing to show that plan to you. You can choose level 1, open view. Now I'm going to draw a profile there. So let's say it's an ellipsoid. Now that plane is over here, so let's draw it here. Let's draw an ellipsoid like that. Now I'm going to go back to the elevation. Let's do again set work plane, pick a plane. I want to pick this guy this time. Let me see if it's going to show. Let's do site. And I want to draw, I'm seeing the profile below it. So let's say this profile is going to be something like this. Now I have a profile here, another profile there, and I'm going to do last one on top. And this guy, let's make it something like that. Now if I go to 3D, I have 3 profiles drawn on 3 levels. And to connect them, I can choose all of them in an order, and I could do create form. It's going to create a lofted form that combines them. And I can do finish mass. Well, the top profile is a bit big. Let's see, edit in place. Let's actually go back. I want to make this a bit smaller. It's like a nice glass, right? So I'm going to finish mass, and the same thing. I could extract the floor plates from it, but you need to create a level for it. So I can make another array. Let's say 20. I'm going to create 20 more levels. Choose the massing, mass floors, intersected it with all the levels. Now you can get the floor plates on each level. And then I can also extract them as floor plates, right? So floor by face, choose these guys, create floor. Now I basically have floor plates there. Yeah, it's basically each floor is using the type parameter, right? So the type is 12-inch generic floor. Choose the massing and do mass floors. And under mass floors, choose all the levels you want to intersect the massing with. Do you see that? Mass floors when you choose the massing. Basically, we are doing in-place massing. So I'm using the massing family properties inside the project to model it in place. But you could also model it conceptually on a separate file. So just like we created the families, there's also conceptual massing environment. So if I go there, open up conceptual mass family, you could set up a parametric massing family here. You could set up different levels. So I could go create more levels. And draw the custom profiles here if I want to. So let's say I want to set up a work plane. My work plane is going to be this ground plane here. And I can draw a custom shape there. Whatever I want it to be. Well, it's not a good spline tool. Let me do it again. Spline 3 points. Well, I actually don't want you to create blobby forms anyway. Let me do just an ellipsoid again. So level 2. So this is a bit like, it also gives you a construction plane so that you can also snap to some alignment to generate floors or profiles. Like level 3. So let's say like that. Now they will be drawn on individual levels, right? And then it works the same way. I can choose these guys, create form, and then if I'm happy with this, I can bring it into the project. And then I can use it here. So now this is the second one I brought in. And I can also again do mass floors. It will, I'm basically bypassing the in-place mass option, right? So I'm generating it somewhere else and I'm bringing it as an object. And if this were to be a parametric mass, you would also have options to control its behavior here. And I'm actually going to upload a tutorial for it so that you can see how this could be done. So you can basically create, just like we did the families, you would create construction planes, annotations, parameters, or maybe rotation values as well. And you will draw profiles for the massing family and then bring it into the project. Okay? Do you guys want me to do a tutorial tomorrow about how to do parametric massing? Huh? How many of you want me to show parametric massing? Okay, I'm going to do the tutorial tomorrow morning. So we're basically going to work in this environment and set up profiles that are constrained by dimensions and parameters, and they're flexible. And the more you set up, the better control you have over it, of course. So when I have 3 profiles, it's just a blobby form that I get. But the more complex you make it, the more advanced it will be. Okay? But whatever you do for the project, make it simple. Okay? Sky is not the limit. Make it simple. I have heard that a lot of times from instructors. Sky is not limit anymore. is not the limit. I see weird stuff all the time in the final, like towers with bellies or like blobby stuff. I really don't want to see any of that anymore. I really want to see. I want to read the massing as massing, like simple proportions, nice proportions, and then you can do subtle movements within that. Okay. So there's a reason why I'm showing you like the absolute towers. Because the movement is subtle. You still see the overall massing, right? The proportions are always there. Right? The boundary is always there. You want to keep that. Same thing with the horizontal ones or the aqua tower. Like the typology is pretty dominant. You still read the overall towers of one, and then the movement is subtle on the facade. So you want to keep it like that.